To run and interpret a one-way ANOVA in SPSS using a rehabilitation-based example. No advanced jargon, no complicated frameworks, just a clear process you can follow and apply right away through rehab academia. In rehabilitation research, we often compare outcomes among more than two treatment groups. If we use multiple t-tests, the chance of making a false conclusion increases. One-way ANOVA helps us compare all groups at once while controlling the error. One-way ANOVA is a statistical test used to compare the mean values of three or more independent groups when we have one categorical independent variable and one continuous variable or continuous outcome. The independent variable is simply the group we are comparing, such as different rehabilitation methods. Usually it is categorical in one-way ANOVA. The dependent variable is the result we measure to see the effect of those groups, such as the balance score after treatment. It must be continuous in one-way ANOVA. The first step is to clearly define your research question. The question should focus on comparing a continuous outcome across three or more independent groups. So, in that case, we may question that is there a difference in balance scores among three rehabilitation interventions? According to this research question, we may extract our variable. For example, suppose we want to compare the balance scores among three rehabilitation interventions. Because there are more than two groups and one outcome, one-way ANOVA is appropriate statistical test. The independent variable is the factor that divides the participants into group. In one-way ANOVA, it is always categorical, such as type of treatment or type of exercise program. For example, Group 1 conventional therapy, Group 2 task-oriented training, and Group 3 virtual reality training. The dependent variable is the outcome we measure. In one-way ANOVA, it must be continuous, such as balance score, walking speed, or any functional outcome-based score. Step 2 is generating hypothesis. The null hypothesis assumes that all rehabilitation interventions produce the same outcome. The alternate hypothesis states that at least one leads to a different result. Before applying one-way ANOVA, we must ensure that some assumptions must be fulfilled, like observations are independent. Independence means that each participant contributes data only once. For example, a patient cannot receive two different treatments in the same study. The outcome is normally distributed within groups. Normality means that outcome data should follow an approximately normal distribution in each group. This can be checked using statistical tests or graphical methods. And variances are equal. Homogeneity of variance means that the spread of scores should be similar in all groups. If this assumption is violated, alternative ANOVA methods should be used. And in the last, the dependent variable is continuous. If assumptions are violated, results may be misleading and the wrong post-hoc test may be applied. In SPSS, normality can be assessed using the Shapiro-Wilk test, while equality of variance is checked using Levene's test. If you may like, I can make another tutorial on how to check normality and variance test in my upcoming videos. Please do let me know in my comment section. To apply one-way ANOVA in SPSS, these are the list of steps which you may go through. First, go to Analyze menu, then select Compare Means and choose One-Way ANOVA. Place your continuous outcome variable such as balance score in the dependent list and your categorical grouping variable such as treatment type into the factor box. Select descriptive statistics and homogeneity of variance to check assumptions. Choose on appropriate post-hoc test and then click OK to run the analysis. So first open your dataset in SPSS. Ensure that the group variable is coded numerically. For example, 1 for conventional therapy, 2 for task-oriented training, and 3 for virtual reality training. The balance score variable BBS should be continuous. Before applying ANOVA, it is important to understand that equality of variance is an assumption, not something we know in advance. We assume similar variances based on study design, and SPSS formally tests this assumption using Levene's test. Now, go to Analyze menu, select Compare Means, and then click on One-Way ANOVA. Move the balance score variable BBS into the dependent list box and move the group variable into the factor box. Click on Options and select Descriptive Statistics and Homogeneity of Variance Test. Then click Continue. Next, click on post-hoc. If Levene's test is non-significant, we use Tukey's test. If it is significant, we use Wells ANOVA and James-Howell post-hoc test. So in that case, we will select both because we don't know. Finally, click OK to run the analysis. And SPSS will generate descriptive statistics, Levene's test, the ANOVA table, and post-hoc comparisons, which we will interpret step by step. Okay, so now we got our tables. Descriptive statistics for balanced performances are presented in this table. Participants receiving conventional therapy demonstrated the lowest mean Berg Balance score, which is 40 with standard deviation 1.83, followed by those in task-oriented training group with mean score 46.50 and standard deviation 1.58. The highest balance scores were observed in virtual reality training group, which is 52.50 and standard deviation 1.58. The overall mean Berg balance score across all participants was 46.33 and standard deviation 5.44. Okay, now coming to the Levene's test. Levene's statistics shows 0.042 and p-value 0.959. Because the p-value is much greater than 0.05, the assumption of homogeneity of variance is satisfied. This indicates that variability in balance score is similar across conventional therapy, task-oriented training, and virtual reality training group. A non-significant Levene's test is a good result. It means ANOVA assumptions are not violated. Okay, now coming toward the main ANOVA table. Because the p-value is less than 0.05, there is statistically significant difference in balance scores among three rehabilitation groups. This is between groups p-value. Therefore, the null hypothesis is rejected. The F value is very large and the P value is less than 0.05, which means at least one rehabilitation intervention produces a different balance outcome. Now coming to the reporting of one-way ANOVA, we can write a one-way ANOVA revealed statistically significant difference in balance scores among three rehabilitation intervention with F degree of freedom to 27, which you may. Okay, so ANOVA does not tell us which groups differ. Because the result is significant, post hoc test must be performed to identify specific group differences. There are two types of post hoc test for one-way ANOVA. Choose Tukey post-hoc when variances are equal and James-Howell when they are not. Okay, now coming to the post-hoc test table. Post-hoc tests are performed only after a significant ANOVA to determine which specific group differ from each other. Because Levene's test was non-significant in your data, so Tukey HSD is the appropriate primary post-hoc test. James-Howell is also shown for comparison and gives consistent results. Okay, so conventional therapy versus task oriented training. Mean difference is minus 6.50 and p value less than 0.001. Task oriented training produced significantly higher balance scores than conventional therapy. Now, conventional therapy versus virtual reality training group. Mean difference is minus 12.50 with p value less than 0.001. It means virtual reality training resulted in much higher balance scores compared to conventional therapy. Now, task oriented training versus virtual reality training. Mean difference is minus 6 and p value less than 0.00. Virtual reality training also produced significantly higher balance scores than task oriented training. All three rehabilitation interventions differ significantly from each other, with virtual reality training showing the highest balance scores, followed by task oriented training and then conventional therapy. Reporting post hoc test in this pattern. Post hoc analysis using Tukey's HSD test revealed that balance scores were significantly higher in task oriented training group compared to conventional therapy group, with mean difference and p value. Virtual reality training demonstrated significantly greater balance scores than both conventional therapy and task oriented training, along with their mean differences and p value. Some common mistakes students do when they are applying ANOVA, like using ANOVA for only two groups, sometimes ignoring the assumptions, and sometimes forgetting the post hoc test. Students sometimes misuse the ANOVA and they may apply multiple t testing, which may create different types of errors. Key take home message: 1 independent variable, 3 or more groups, 1 continuous outcome, always check assumptions. In case of significant ANOVA, go for post hoc test. One-way ANOVA is a powerful and commonly used test in rehab research. When used correctly, it provides valid and meaningful comparisons across multiple interventions. I hope this tutorial was helpful. For more content, follow Rehab Academia. Thank you.